Okay, it's officially 10 o'clock, so we're going to get started. My name is Mark Allen, and I work at AlertLogic, which is in Houston, and I, for a long time, worked with Glenn, and just really happy I could come do this talk. I did this talk at the PyHouston meetup. Did anyone see the talk there? Okay, good. Yeah, everyone likes to hear the same talk again, right? Yeah, I think I'm an okay speaker, but I don't know if I'm that good of a speaker. So how many people here have used DTrace before? One person? How many of you know what DTrace is? Cool. All right, so hopefully what we're going to dive into here is some ideas about how DTrace can help you make your Python programs better. So the first question we want to answer is, what is DTrace? It sounds a little flippant, but DTrace is really focused on dynamic tracing, and that's what it stands for, as opposed to static tracing. So you may be familiar with tools like strace and truss and stuff like that. You know, programs that go through C code and tell you what sort of libraries they're connecting to, what the calls are into the library routines and that sort of thing. Those are considered to be static tracing tools because they really focus, they follow the program flow of the application as it executes. And you think, well, that's really what I'm after, but DTrace is a more powerful tool because what it allows you to do as a user is specify what sort of probes that you care about. So you actually get to decide from your tracing technology what sort of things you really care about. And we're going to get into all of that stuff, especially as it regards Python during this talk. So something else that comes up all the time is, we've all written code like this where you say, okay, I've reached this point in my function, I've reached this point in my application, I've logged a certain message into syslog so that I know that I did this thing and this other thing and that the program executed A and then B and so forth. Or even we've done a profiler, like there's this really neat decorator called @profile. The URL's at the bottom of the slide. It's a really cool profiler, actually. And it helps you decide, well, this thing's really slow. Why is it slow, right? That's a question that a lot of people have is, how long does it take to execute this code path, and what is the hottest code path in my application? And if performance is a concern for me, how can I make that hot code path execute in the most efficient way? And a lot of times, trying to measure that accurately, especially as we go through all the different layers of an application, is really tough, even if you have a really nice profiler like this one. So DTrace is really an observability technology. You think, well, what does that mean? What it means is that as you traverse through your application, you get to look at all the different layers. So DTrace can examine every single layer in this diagram, all the way from your application code into the system libraries, down into the system calls, and even into the kernel itself. You get a level of visibility that you just can't get with any other tool. One of the other programming languages that I work with very frequently is called Erlang. Erlang is a massively concurrent language, and it has a built-in scheduler. And even Erlang itself cannot tell you what the scheduler is doing, but DTrace can. So it just gives you a level of visibility into areas of your application, even ones that are really difficult to look at accurately. So DTrace is a really neat technology. The next slide that I want to tell you about is prefaced with a little story, so if you'll just indulge me for a minute. There was a physicist who was giving a lecture once, and he was talking about how the Earth rotates around the sun, and there was a woman that stopped him on the way out, and she said, I thought your talk was really interesting, but the Earth actually is on the back of a giant turtle. And the physicist said, well, what's holding up the turtle? And she said, you're not going to trick me, it's another turtle. And he said, what's holding up that turtle? And she said, well, it's turtles all the way down. So with DTrace, what you get to see is that it's really turtles all the way down in your code. It's just handy like that. All right, so let's show some concrete examples. These are things that you can do with DTrace, although I don't have enough time in my talk to show them to you today. But once you get DTrace comfortable, these are definitely things that you can do. You can trace socket accepts, right? You can figure out why your application is executing in a certain way, in a certain pathway. You're like, well, it should go down this pathway, but it's actually going down this pathway. So DTrace lets you look at the emergent behavior of your code, which is pretty slick. You also can profile other things, like maybe you have an application that sits on top of NFS, and sometimes NFS just gets really slow, and you're like, why is it really slow? And the sysadmin guys that you work with are like, I don't know. You can actually use DTrace to help profile that sort of thing. It can tell you all of the internal state of those underlying protocols that your application sits on top of. Also in conjunction with the behavior of your application itself. So if you open a particular file that's on NFS and it's really slow for some reason or whatever, DTrace can help you understand why it's slow and maybe even tell you how to fix that problem. One of the things that's come up, I've done this talk a bunch of different times now. I did it at OSCON and I did it at PyHouston. But one of the things that people keep asking me about after the talk, and which is great, I love questions by the way, is, what about DTrace and a profiler? It's like, well, I already use a profiler. Why would I want to use DTrace? My answer to that is that, DTrace is really not so much a competitor. It's more of a complement. You want to use DTrace and a profiler, right? A profiler is going to have the most specific domain knowledge about Python. DTrace is a generalized tool. It's intended to be something that shows you how different parts of your computer environment work, and not just Python, but also MySQL or Postgres or NFS or all of these other things that go into building an actual application. So if you want to have specific Python domain expertise, you want a tool that understands Python very well, right? So that's a profiler that's written in Python probably. And you want to use DTrace to help you get at those questions that are very difficult to answer in the context of just Python. Another one that people ask me is, what, I already use debuggers, right? I do print statements, or I use PDB or whatever. Again, it's the same sort of thing. You want to have DTrace in your tool belt for those times that debuggers can't tell you the information that you want to know. And that's why it's really great. So DTrace only runs on specific operating systems. It runs on Solaris 10 and 11. It runs on Illumos, which is a fork of Open Solaris. There's a couple of children of Illumos. One is called SmartOS by Joyent. Joyent is a cloud provider. And there's also OmniOS from OmniTI. FreeBSD 9 and greater have DTrace probes. And OS 10, as of Mountain Lion, has DTrace built into it. So if you have a Mac, then you already actually have DTrace enabled on your system. So I have a Mac because I'm a fanboy, and so I use DTrace. My daily driver in Python is a DTrace enabled Python. I'll tell you guys how you can build your own DTrace enabled Python in a little bit. One other question that comes up all the time in this talk is, what about Linux? Well, as you guys know, Linux is not on this list. Unfortunately, there's a lot of sort of esoteric licensing reasons, not like technology reasons per se, but there's licensing reasons why Linux is not on that list. There's a guy in England who, sort of as a hobby, more power to him, wrote a kernel module which implements about 40% of DTrace. It's called DTrace 4, the number 4 Linux, and it's on GitHub. It does actually work fairly well, but it does not support application level tracing. It only supports sort of kernel level primitives and stuff like that. So unfortunately, that particular module does not work with the stuff that I'm going to talk about today. To use the stuff I'm going to talk about today, you really have to be on one of those 4 operating systems I mentioned: Solaris, sort of OmniOS, SmartOS, FreeBSD, or Mac 10. If you're running on Linux, you can do DTrace on them, on that one, but only for kind of lower level type probes. Are there any questions before I go into the next section? There's a lot to digest. Yeah. What's
as you were going through with Ubuntu, there's a DTrace dependency installed. Do you know anything about that?
Yeah, so that's a great question. One of the other things that's very confusing about Linux, the Linux environment, is that when the Linux developers decided not to incorporate DTrace into their kernel, there was a secondary project that got started up called SystemTap. SystemTap purports to be much like DTrace, but it doesn't supply all of the sort of safety guarantees that DTrace provides. And I personally don't trust SystemTap enough to run it in production. I do trust DTrace enough, and I have run it in production. So SystemTap's available on Linux boxes. If you type DTrace, a lot of times you actually end up with SystemTap. There are certain distributions like Ubuntu, for example, where they may actually have incorporated that kernel module I talked about earlier, so you actually get the sort of DTrace safety, but you don't get all of the full richness of DTrace itself. So unfortunately, Linux is sort of in this crippled state. I also heard at OSCON that Oracle is porting the full DTrace stack to their fork of Red Hat. So it sounds like at some point in the near future, there will be some kind of support for DTrace on Linux, but only in sort of Oracle's proprietary fork of Red Hat, which sounds like a very strange thing to say, but yeah, so I don't know how they're going to do all the GPL stuff around that. All of that's still up in the air, unfortunately. I wish there was a better answer for Linux, because I know, how many people here don't deploy on Linux? Yeah, no one. So, you know, it's just a tough situation where if you're deploying on, if you're testing on Red Hat, or I'm sorry, if you're testing, you know, building on OS 10 on your workstation, and you push it out to a deployment that's, you know, on Linux, and then you lose all the visibility from DTrace. So it's kind of a sad story, but that, you know, that's where we're at with this, unfortunately. So we just have to make do. You know, DTrace, like a lot of technologies, has its own sort of esoteric terminology. I just wanted to go through some of those real quickly, so that when you see these things in blog posts or whatever, man pages, you won't be confused. So there's this notion of a provider. A provider's technical definition is that it manages a probe. You're like, what's a probe? Well, a probe is a DTrace observable. So it's actually an event that you care about. You think about a probe as being, yeah, it's really just an event. So, you know, say that whenever a file opens that you want to start a DTrace probe, you know, you can specify whenever a file gets opened by the kernel, I want you to start tracing operation X, Y, and Z. And then aggregate that and report it back to me. So that's what it is. In our case, a provider is actually the Python binary, at least for the specific part of this talk. There are a lot of other providers in DTrace. I've already alluded to several of them. There's sort of network application level things like HTTP, FTP, NFS. There's, you know, kernel level stuff like TIC. You know, you can instrument TIC if you want to. There are the SBT, the system boundary trace, which is basically the handoff between a system library and the kernel. That's fully instrumented in all of the operating systems that I've mentioned. So there's just a bunch of different providers. In fact, there's about a 1,300-page book that weighs like 5 pounds that describes all the goodness that is in DTrace. I highly recommend the ebook. It's much cheaper and just as comprehensive. It also is searchable, which is super handy, and it's published by Pearson. They occasionally put it on sale, and usually when they do that, I tweet about it. So if you want to follow me, then you can buy it cheaply. Right, so we talked about probes, we talked about providers, and the last term I want to mention here is a consumer. A consumer is really just a program. So DTrace has its own scripting language called D. I'm going to describe it for you in a couple of slides. But basically a consumer of DTrace is a D script. So it's a script where you specify what probes you care about, what actions to take, and what predicates to match. So let's get into that right now. These next slides are about the basics of the language. So D itself, the scripting language, is very awk-like. How many of you have used awk? Oh, good. All right, so if you have some familiarity with awk, you're going to have some comfort with D just kind of coming into it you know, cold. Basically, the basic structure is that you want to define a probe and a predicate and an optional action. So the probe and the predicate and the action are optional. D also supports begin and end blocks, just like awk. So you can say things, before you do everything else, here are all my local variables. After the end, this is how I want you to, you know, aggregate things and sort them and, you know, truncate them and so forth. So D does support local variables. It has this sort of very strange syntax of calling them some arbitrary atom and points to an arrow, which is the actual name of the variable. And you can assign it sort of an arbitrary value. It also does aggregate and associative arrays. You prefix those with an @ symbol. It's a little Perlish in that sense. And it also has one-liner support, like I showed down here at the bottom of the slide. So this is what it looks like when you like cat out a script or something. Typically when people write D scripts, this is what they usually look like. So let's look at an example script here. This is a really simple example. Python has a couple of probes. One is called function entry and function return. Does anyone want to guess what those do? Yeah, so every time a function is entered by Python and exits, this probe will fire. And then what we're telling, the action that we're going to take here is actually we want to trace, which means every time that a subroutine is entered, I want you to store that and print it to the screen. And this copy in str, arg1, means because DTrace sort of lives in this weird space between the kernel land and the user land, it has these sort of helper functions that essentially mean copy this data from user land into the kernel, and then the kernel is the one that's actually writing stuff to your screen. So that's what the copy and stir things means. But trace essentially means every time a function's entered and returned, I want you to keep track of the depth that you're at, and also tab it out so that you get this nice sort of Christmas tree-like trace of your program execution as functions are entered and returned. And then the last part that's really important in this is the flags that are up here. Sort of oddly in DTrace, flags are very important. The -Q means that I don't want you to write extraneous messages to my screen. The capital F means I want you to keep track of the trace depth. And the Z means that it's okay if the no probes match this specification. And S means here are the probes that I care about immediately following S. Yeah, so it's a lot to take in. Are there any questions about this or anything that seems a little weird or unclear? Yeah, in the back.
What did the N1 flag back to? -N flag?
Oh, you mean here? Yeah, great question. So DTrace has two different flags. One's -S, which means at some point in the future, I'm going to enumerate some probes that you should care about. -N means immediately following in, this is what I want you to look at. So -N is really for command line, one-liner type things, and -S is really for scripted files that you would actually chmod 755 and execute on your workstation. Great question. Thanks. That's good. So there's that. Are there any other questions before I move? Yeah. Yes. You mean the question was, how do you know that the Python, what are the Python specific probes, basically? Yes. I know that because they're documented in the DTrace stuff that comes with Python. And I'm actually going to tell you what all of them are in this talk. So, so yeah, that's how I know that they're Python specific, and I know what their arguments are. And hopefully at the end of this talk, everyone in the room will know too. So yeah, thank you. Good question. I have another example here. It's a little bit more complicated. But I don't think it's the action that it takes is a little more complicated, and it is a bit more of a code block in terms of like eye strain. But it's kind of the same idea here. Again, you see that we have the function entry probe. All right. So that's the probes we care about, and then we have an action in there. We're going to unpack what all that means, and then there's an end block at the end. Again, we're going to unpack what that means too. You see this thing here in the middle, it's sort of a monstrosity, I'm sorry about that. The idea here is that we want to aggregate stuff. And all these stir joins and copy and stirs are essentially copying data from user land, and then the kernel is joining them together into a single string. So in this case, as you can see from the comments, that arg0 is the source file name. So in this case, every time a function's entered by the Python interpreter, I want DTrace to collect the source file name and append it a dash and then the function name, right? So say that I had like source file.py, and then in that I had some def that was like do something. So every time that function gets entered, it's going to output that into this associative array, because there's an at sign at the front of this, if everyone can see that. So actually what we're doing here is we're counting things. So every time function X gets executed in source file Y, we're going to increment a counter. And then, so we're going to do that over the entire run of the program. And then at the end of this, see there's the count stuff. We just went over that. At the end of this, in the end block, I have this function called trunk. And what that means is I want you to take the top 10 results. So give me the 10 most called functions and what file they're in, and then throw away everything else, because all I care about is the top 10. Those are the only ones I want to look at in terms of, okay, here's all my hot code paths. So I wrote a module that's on PyPy. It's called PyGet. There's a file sharing, photo sharing website called ge.tt that I used to use very frequently. And so I wrote a client library for it in Python. And this is the unit test that I decided to do DTrace on. So you guys could see what the hottest code paths were in that particular application. And interestingly enough, you can see that the URL lib and then a whole bunch of regex parsing. So I'm not sure what the regex parsing is all about, but it's really hot and it gets used. In fact, the most, there's an iterator in there that gets used 4,202 times. So the cool thing, one of the cool things about DTrace in Python is that it doesn't just show you your application, it shows you all of it. So it's even stuff that's in the standard library. There is one caveat that I wanted to tell you about, and that is if you have something that uses the C foreign file interface, so if you use the CFFI, to like call into a C library or something like that. Unfortunately, that's not supported with the Python DTrace probes. So if you have a lot of stuff that calls into C libraries from your Python code, then DTrace is not going to be a terribly good observability technology, unfortunately. That's just a limitation of how Python interacts with C libraries. But as long as it's pure Python, or at least mostly pure Python, then you're going to have great observability into the behavior of your application. Let's talk about some of the aggregate functions. DTrace has a really, really rich set of aggregate functions. So these are things that operate on the front of those at variables. Things like average, count. We've already looked at count, so you guys know what that does. Average does what it says on the tin. Sum, again, obvious. Min, max, again, obvious. I wanted to spend a few seconds talking about the quantize actions. These are actually really cool. One of the things that DTrace is really great about helping you understand is outliers. When you use a profiler, in general, what happens is that as you execute a piece of code, say 100 or 1,000 times, the value you get back from the profiler is actually the average of 1,000 times running through that code. That's fine, right? Like that's, as far as giving you an indication of what your performance is, that's a good number. But the thing that you lose in an average is the outliers. So the things that you would typically not see very much is, say that 99% of the time it takes 500 milliseconds, and 1% of the time it takes 2,000 milliseconds. That 2,000 millisecond time is just going to get washed away in the number of iterations that you go through that code base. So what DTrace helps you do is actually you can build histograms built into the language, and that's what these quantize functions do. So as you collect information in an aggregate variable, you can actually tell DTrace, I want you to build a histogram of that data that I've collected, and it will go ahead and slice them up either into a linear histogram or into a log power of 2 histogram, and then you'll be able to see outliers. You'll be able to tell, well, okay, I have this weird like binormal distribution where I have a spike here at 500 and I have a spike at 1,000. What's up with the spike with 1,000? You can sort of turn the knobs in DTrace and zero in on why is this taking so long, in these 5 specific cases or whatever. That's what DTrace can really help you do. It's a really powerful tool for figuring out why some things are slow and why some things are not. It's pretty cool. Are there any questions about this part before I move on to the next one? Yeah.
Can you name arg0, arg1 as well, the associative array that you declared the at symbol?
You mean back here?
Yeah.
I'm not sure I fully understand the question. Are you asking, can you name your associative array arg0 and arg1?
No. Can you rename arg0, arg1 as well, the associative array that you declared as the at symbol? Can you repeat the question, please, so we can?
Yeah, sorry. The question was, can you rename what arg0 and arg1 are, and can you name an associative array? Yes, you can name an associative array pretty much any value you want that's not reserved by DTrace. You cannot rename the args, unfortunately, because they are set at C. They're written in C, and there's a special shim that essentially gets built on demand when you do probe. So the active probing with DTrace actually activates those shims. I was going to get into this a little later in the talk, but what happens is when you activate a probe in your program, there's a bunch of no-ops that get put in when it's not active, and when those things are active, then those no-ops actually turn into executable code. So you can't rename the argument names because they're set at C at compile time when you build your interpreter. But I am going to tell you what all the arguments are and what order they come in. So hopefully that will make things a little bit clearer. Because I know right now it feels sort of like a black box, and I don't want it to feel like that. So, but we'll get through that. So one of the things that's really interesting about DTrace and Python together is that Python is one of the only programming languages that I know of that doesn't come with DTrace support sort of out of the box. You have to actually sort of go out and get it yourself. And I don't quite understand why that is necessarily. I wanted to ask Nick if he knew anything about that, but I didn't get a chance to. So if I see him after the talk, I will try to find out. But so far, I haven't heard a good answer for that. But there has been some sort of decision somewhere that DTrace was not going to be part of core Python. And because of that reason, the easiest way to build your Python with DTrace is to use the homebrew stuff. And homebrew is very focused on OS 10 specifically. So if you're running OS 10, homebrew is a great way to get your Python with DTrace. And in fact, you just execute the little command that's on the screen there, and it will go ahead and happily build you a Python with DTrace. One of the other things that I did for this talk was to extend a tool called Pythons. There's another tool called Python Brew, which I like, but it doesn't seem to be under active maintenance anymore. It looks like it got abandoned. So this dude, he's Spanish. I can't remember what his real name is, but his GitHub ID is Sagol, or maybe it's Sagol, I don't know. But so he wrote this tool. It's sort of a fork of a Python brew called Pythons, and I added the ability for you to build DTrace-enabled Pythons 2.7. So anything in the 2.7 series. With the patch. So it will go ahead and download the patch, patch your Python, and install it into the Python directory, and then you can go ahead and throw that into your virtual env very, very easily. In fact, that's what I do all the time when I'm developing in Python. So my daily driver, as I said, is DTrace enabled because I extended the Python tool to make it simple. We've been having a bit of a back and forth, the author of this tool and I, about what the best thing to do is, the policy for applying DTrace or not. I think it should be optional, but he wants it to be sort of out of the box. That makes me feel weird because I think there are people that might not appreciate that for whatever reason. So I haven't actually taken this forward. It's kind of just been sitting out there for a couple months. But yeah, I need to get back on that and try to get it going. So the Pythons tool or Homebrew are really the easiest way to go about this. If you're running Python on OmniOS or SmartOS, just because you want to play with it, those are both available through Vagrant and also on EC2. Or actually you can sign up for Join and play on it there. Those particular Python interpreters also don't have DTrace enabled by default, which is very strange to me because those guys are like the biggest DTrace fanboys in the world. Maybe it's just because of the whole it doesn't come out of the box type thing. I don't know. But anyway, that's a good way to do it. There's a way for you to programmatically tell if your Python's DTrace enabled. If you have a DTrace support compiled into your interpreter, you can actually import DTrace, and then it has a single attribute called available, and it will return true. If you don't have DTrace enabled, you'll get an import error. Of course, DTrace.available won't return anything because it's not imported. So that's a good way to tell if you're in an environment where you have DTrace available and want to use it. So that's a good tip. Here's the part where I wanted to kind of go through the various functions. Before we start doing that, are there any questions about how to build DTrace enabled Pythons? No? Okay, cool.
How hard is like the next year version of building it like minimum?
Oh, you mean like from source or whatever? It's not too hard actually. The hardest thing is tracking down the patch. There's a bug on the python.org site. I think it's 13.138 or something. And it actually has a patch for 2.7, and it has a sort of a larval patch for 3.3, I think. Hopefully, DTrace is going to go into Python 3, but I haven't heard definitively whether or not that's going to happen yet. But my hope is that it will, because I think DTrace is a great tool, and once you get used to using it, it's kind of hard to not use it. But yeah, you can definitely build your own if you want. Just track down the patch and apply it and build your Python. I will tell you that the caveat is that the patch that I have seen most commonly does not apply cleanly to 2.6. So if you want to build a 2.6 DTrace, I don't know what to tell you. You'll have to, do it yourself. You're really into neckbeard territory at that point. So, yeah. But I wish you luck. Yeah. It is fun. It's fun to mess around with the compiler and stuff. And it's even more fun to automate it so you don't have to do that anymore. Yeah, that's my philosophy about compilers pretty much. Don't. All right, so this is the first slide that kind of talks about the various probes that are available for Python and DTrace. We've already talked about function entry and function return. There's a really interesting probe called line. And line executes whenever Python advances through a line. And you're like, wow, why would I need to do that? Well, because of the way that you can combine probes and predicates, you can actually tell DTrace, I only want you to probe line 100 through 120 of my script. Okay, that's the only part I care about. I don't want you to tell me anything else about any other part of the program. Only when it's between 100 and 120, that's what I really care about. That's what the line probe gives you. So it's pretty cool, and it has 3 arguments. Those are detailed down there. arg0 in this case is the file name, arg1 is the function name, and arg2 is the line number. So using those 3 arguments with these probes, you can do just an amazing amount of probing. In fact, these are the probes that I use most frequently myself. There are many other probes that we're going to talk about. In fact, some of the new ones at the end are actually kind of cool, but I haven't really played with them too much yet. So function entry, function return, line, and then the arguments. There's one called GC start. So every time Python starts a garbage collection cycle, the argument to this, arg0, is the generation. It's similar to the information that you would get back from gc.collect. So if that helps anyone. There's also, of course, one for GC done. So after garbage collection is finished, again, this can help you isolate performance issues, or why is Python being really slow, or things like that. You can detect, okay, well, I'm in a garbage collection cycle here, so I know that the interpreter's really not going to do anything until it gets done with that. DTrace can tell you when it's doing it and when it's done, and it can also tell you how much stuff it got rid of. That's the arg0 for GC done. This is the last set of slides, or the last set of probes. Sorry, I still have some more slides to talk about. Sorry. There's these 4 probes are actually really kind of cool. And I haven't played with them that much yet, but I think that they have a lot of potential to do some really interesting profiling work. So the first 2 probes, of course, are whenever you instantiate a new class. So the first probe fires when you start instantiating a class, and the second probe fires when it's done instantiating a class. So at that point, an object has been created and returned to you of type, whatever, X. And then the bottom 2 are ones where you actually destroy those objects. So those are when you want to get rid of them. You've disposed of them, they're out of scope or whatever. Those are instance delete start and instance delete done. Again, you can time those events. You can see what your code pathway execution is. You can see what lower level things, like maybe you need to clean up database connections when you destroy an object. These are things that will help you detect that and really drive into the emergent behavior of your application. In this case, arg0 is class name and arg1 is the file name. So you can say, well, I got class X from file Y, and you can see when those things happen and what happens in between them. One of the other things that's really neat that I just found out about a couple months ago is that you can write your own DTrace probes in Python. There's a library on PyPy called Python DTrace, and it's also available at this GitHub URL. It's really kind of interesting because DTrace has a facility called Userland DTrace, so it's USDT, and it's a C library, but what it lets you do is hook the goodness of DTrace into arbitrary probes that you build yourself in a language that you are already comfortable with. So you can say, whenever custom probe 1 fires, then I want you to execute this callback. And you can do all sorts of data collection, or you can traverse through data structures, or dump stuff to standard out, or log it to disk, or send it to a database, or whatever you want to do. The sky's the limit with this. You have the full power of Python available at your command to do things when DTrace fires. So it's pretty slick. If it's something that you want to check out, I would encourage it. The last little bit here that I have is about DTrace Resources. I just wanted to spend a couple of seconds talking about the various ones. The first one is actually, I think, the most interesting link. It's called DTraceHOL.com. At Oracle's, I don't know what they call it now. I guess it's Oracle World or Oracle One or something. They had a custom, they had a class where they were teaching people hands-on. So HOL stands for Hands-On Lab. And what DTrace Hands-On Lab is essentially is it's a virtual box. So it's the virtual box container that has an image of Oracle 11 on it. And it comes out of the box with, I think, 13 different exercises that go along with that virtual box image. So you can download the virtual box to your system, fire it up, go through all the labs. It'll get you very familiar with DTrace, how it works, what probes are available, what sort of things you can combine together, and it's step by step. I mean, it's literally like recipe, step 1, do this, step 2, do this, step 3, do this. So it's a great introduction to the technology, and it even helps you, even if you don't have, if you're on Windows or something and you don't have DTrace available, you can still run it inside this virtual box and play around with the technology. There's 2 other resources on the internet that are really great. The first one is dtrace.org. It's kind of the personal website for a bunch of the people who wrote DTrace at Sun in 2005. They're still writing about DTrace now. Most of them work at Joyent. And they're still publishing really, really fascinating stuff about DTrace. One of the guys that has kind of written the most DTrace probes is a performance engineer named Brendan Gregg. And he just published a new blog post a couple days ago that was on Hacker News too, about flame graphs. So what he does is he'll take DTrace probes, and every second he'll just dump a bunch of stuff, and then he has a post processor that he wrote to generate a flame graph SVG, which he can show in the browser, and it'll actually show you over time how much memory is leaking out of your applications. It's really, really cool stuff. So you can access that at dtrace.org. There's a great preface to DTrace, which I've linked up there. This is the second URL. The third URL, I mentioned earlier, there's this 1,300-page book. Brendan Gregg is one of the authors of the book. Jim Morrow is the other guy, which is actually how I kind of got into DTrace. And all of this, while the contents of the book are not available online, except for sale. But the cool thing is that all of the D scripts in the book, so all of the actual executable source code, is available at this website, and you don't have to buy a book to use that. You can just go download them. They have something like 400 or something DTrace scripts. There are all kinds of different system activities. There's probably about 15 specific for Python alone. So it's a great resource if you don't want to write your own DTrace scripts, if you just want to use it like a black box. You can go there, see what kind of scripts are available, and start using them. You don't have to understand really anything about how DTrace works to use them. You can just go and grab them. I've linked specifically to the Python scripts there, but as I mentioned, there's just a ton of them. There's over 400 of them. The last link is a link to the DTrace book that I talked about several times. It's available on Amazon. I think it's about $40. And I personally own it in ebook format. It is a great resource to have if you want to learn all about DTrace or you need to have a reference for DTrace. It's really great. And with that, I'm pretty much out of slides. So thank you for your attention. I appreciate your time. Are there any questions about the talk?
Are there any other languages that have really good DTrace support that you've used?
Yeah, there's several. So the question was, are there other languages that have good DTrace support? Yes, there are actually, I think DTrace is well supported in Java, JavaScript, Perl, Ruby, Erlang. Those are the ones that I would probably be most interested in myself. PHP, for whatever reason. I guess, yeah, I shouldn't probably say that on film. That's right, I'm on camera. So there are tons of different languages that have DTrace support, and in fact, almost all the major languages you can think of. Of course, the ones that Joint cares the most about is JavaScript. So I would say at this point, JavaScript probably has the best DTrace support. Erlang has insane number. It has over 40 different probes that it can fire, which is crazy and also cool. But the thing that's really funny about Erlang is that the documentation for it is really bad. So you actually have to, at least when I was doing my talk about this at OSCON, I had to actually go in and read the source code several times to figure out what this probe does and how it works and what arguments it takes. So fortunately, Python and most of the other languages like that have great documentation for their DTrace probes, and most of them, except for Python, pretty much have DTrace available as a compile option. So they all have .config scripts, and you can pretty much do .config -- with DTrace, and it will go ahead and build you a DTrace-enabled interpreter. Yeah, question?
Yeah, I'm a Mac guy. You appear to be a Mac guy. Instruments tool in Xcode is DTrace.
Yes, it is. So the question was, there's an application in OS 10 called Instruments, and it uses DTrace under the hood, and that's 100% correct. The question was, does Python work well with that? It does, as long as you have a DTrace-enabled Python. So if you don't, then it obviously isn't going to work.
So all we have to do is get the Pythons as you showed up there.
Yeah. Yep, pretty much. That's what it takes. Like I said, I personally don't like to overwrite my system Python. That's madness. But doing it in a virtual environment is pretty cool. So, yeah. Question?
Do you have the idea if PyPy has DTrace probes?
The question was, does PyPy have DTrace probes? I don't know. That's a great question. I don't know. Another question, yeah.
Your example of Pythons used what appeared to be Python 2.7.5.
So Python's, as far as I know, only builds 2.7 or 2 series stuff. Although I might be wrong about that. But the patches that I have are only for 2.7. So that's the only part that's in this pull request that's open right now. Like I said, the status of DTrace in Python 3 is still open as far as I know. There has been a very conscious decision not to include it in 2. I don't know the rationale for that. I wish I did understand it, because then I could at least, be at peace with it. But it's just one of those things where it's like, no, we're not going to have it, or something. I don't know. But yeah. So I don't know when or if Python 3 is ever going to have DTrace in it, but hopefully it will. So yeah, I'm going to try to buttonhole him and ask about it. Are there any other questions? All right, well, thank you very much for your time. I really appreciate your attendance. Thank you.